So welcome to our first standard, to standard 1.1, which is looking at the scientific notation or standard form, how you might see it. And as we could see, it is used for writing very large or very small numbers. And it's such a standard way of writing numbers of all different sizes. So let's jump into the definition, scientific notation or standard form. So there's a couple of criteria that we have that we need to be able to do. You probably have already seen this in other classes, but we're just going to review it. So the scientific notation comes in the form, let's say, A, which is our coefficient, times 10, base 10, to some integer, we'll call it K. And the rules are that A needs to be there, or the coefficient needs to be between 1 inclusive and 10 exclusive. So, for example, 3.9 is a good number. It's a good coefficient. It's between 1 and 10. And we could say times 10 to the, let's say, 25th power would represent a number, 3.9 times 10 to the 25th. That's scientific notation. Check it, meets all the criteria. In contrast, let's just see a counterexample. If I were to show you the number, maybe, 15 times 10 to the 7th, right? This is not scientific notation because of the coefficient, which is not between 1 inclusive and 10 exclusive. Here's just a quick example. They want us to make sure that we know how to write the number 3,500,000 in scientific notation. How do we do so? If we have to do so, we start with the first significant digits, which are in this case 35. 35 by itself is not a good coefficient. So we have to put the decimal in between in order to make it between 1 inclusive and 10 exclusive. And then to make it equal to what we see up there, we're multiplying it by a power of 10. And that power of 10 is going to be the number that takes 3,500,000. 1, 2, 3, 4, 5, 6. So I took that decimal point 6 times. So this would be written as 3.5 times 10 to the 6th. One more example of a very small number. Here we have 0.000042. So now, again, my first significant digits are going to be this 42. That is not a good coefficient, right? It doesn't meet the criteria. 4.2 would meet the criteria. And I'm multiplying that by 10 to the, and we have to see which power is it going to be now. So we put the decimal point here between the 4 and the 2. And I would be counting 1, 2, 3, 4, 5. I counted backwards 5. So this looks to be times 10 to the negative 5. 4.2 times 10 to the negative 5 looks to be that number, the number 0.000042. And now let's take a look at if you have to do operations with scientific notation. So for example, you might need to do what we see here, 2.3 times 10 to the 5th plus 4.1 times 10 to the 4th. Notice that we have different bases. It's not 10 to the same base, so it'll make it difficult to add, or we can't really add this way. So one way that we could fix this problem, we could convert one of the 10s to the same base. So maybe I could make this here become equal to, I want to have 10 to the 5th power, I want to have the same base as the one next to it. And if I'm going to make that 10 one factor larger, I have to make sure that I make that 4.1 one factor smaller to keep everything equal. The other side I'm fine, 2.3 times 10 to the 5th. And now, now we can easily add the coefficients together. 2.3 plus 0.41 is going to be 2.71 times 10 to the 5th. And that's still in scientific notation, so that would be our final answer. Here we have it even easier. It's multiplication, because with multiplication, we don't really have to worry about the different degrees in the 10. We can just multiply everything across, and that's what I'll do. So I'll take my calculator, and I have 2.3 times 4.1. So I multiply the coefficients. That gives me 9.43. 9.43, which is a good coefficient. And 10 to the 5th times 10 to the 4th, the law of exponents tells us that is 10 to the 9th. The exponent over the 10 is an integer. The coefficient is between 1 inclusive and 10 exclusive. We have a good scientific notation. And here they gave us some real life examples if you want to practice. Not too difficult here, right? The population here of India, we could just move this decimal point over 9 times. So from that 1.3, 6, 7, so I moved it over 1, 2, 3, and now 4, 5, 6, 7, 8, 9. And that in non-scientific notation, we could see it written out, and that looks to be 1,367,000,000 is the population. And we can do the same thing for the speed of light, but I guess I'll just do the speed of light also. 3.00 times 10 to the 8. I moved over that decimal point once, twice, 3, 4, 5, 6, 7, 8. And that would be meters per second. And that is 300 million meters per second is apparently the speed of light. And if I were to do Planck's constant, that's going to be, I'm not sure if I have enough space on the screen, but we see that it starts off 6.63. And then what's going to happen, I would be having 0, 0, 0, 0, 0, 0, right? You get the idea. I'd have to move that over a bunch of times, pretty much 34 times, which will give me Planck's constant. Obviously, it's much easier to write that in scientific notation. And then I'll just do question number 1 here, which is fairly straightforward. So we actually have 2 questions here. We'll see if we have time. So this is asking us how far away is the nearest planet to Earth, given that they tell us it's 4.24 light years away. And how many kilometers is that? And they tell us that each kilometer is 9.461 times 10 to the 12th. So what I could do now is I can just multiply my 4.24 times 9.46 to the 1. That gives me 40.115. So I multiplied out. So what I did here was 4.24 times 9.461 times 10 to the 12th is equal to, what I have there? It was 40.115. 40.115 times 10 to the 12th. And now that 40 is not in scientific, that 40, the coefficient is not in the correct form for scientific notation. It's not between 1 and 10. So you would have to convert this. If you got this as your final answer somewhere on your test, you would want to make sure that you convert this to a number between 1 and 10. So I would write this as 4.0115. And if I do that, in other words, I shifted it 1 decimal point to that 1 factor to the left, I have to make sure that I add on 1 factor to my 10. And that would be the final scientific notation form of that problem. And then I guess for the last problem here, we just have a simple calculation. Let's see, it is 2.4 to the 5th power, 2.4 to the 5th power. Take away 3.1 to the negative 3. And then we take that to the square root. That's going to be a fairly straightforward number. 8.9. It's really 8.921. So 8.921. If I want to put that in scientific notation, it would be fairly straightforward. Just times 10 to the 1 power. Right, and that we can just leave it really like that. Right, so that is our first standard, 1.1. Very straightforward. Just remember the main definition. Your coefficient in scientific notation needs to be between 1 inclusive and 10 exclusive, multiplied by a factor of 10. Right, and then you should be good with that. Right, see you for the next standard.